Let us solve another question on cache memory, which was given in GATE 2014 for 2 marks. The question is as follows. In designing a computer's cache system, a cache block or cache line size is an important parameter. Which one of the following statements is correct in this context? A smaller block size implies better spatial locality. A smaller block size implies a smaller cache stack and hence lower cache stack overhead. A smaller block size implies a larger cache stack and hence a lower cache hit time. A smaller block size incurs a lower cache miss penalty. Just look at this question and try to understand the things that are given here. The thing is, he's talking about the cache system, and he's precisely talking about a block. Okay, and this block can also be called as a line. We know that. The block size, of course, it holds an important parameter. Okay, now he's talking about a smaller block size. If the block size is smaller, then it implies a better spatial locality. This is the first thing. If the block size is smaller, then he's talking about tag will be smaller and lower tag cache tag overhead, meaning the total tags in the cache will be limited. That is, the cache directory size, the tag directory size will be limited. The third one is, if we do have smaller blocks, then the tag will be larger, so the tag directory size will be increased. This is the third assertion. And the fourth assertion is, a smaller block size incurs a lower cache miss penalty. And just let us have a look at all these options and try to rule out all the false options. The first one will definitely be ruled out because a smaller block size implies, of course, the worst spatial locality. What is the spatial locality? In addition to the current accessed element, all the remaining elements which are in the same block from the main memory will get transferred to the cache memory, right? So in that light, in that context, more the block size, more the spatial locality. Less the block size, less the spatial locality. So this will get ruled out. And the second one is, smaller block size implies smaller cache stack and hence lower cache stack overhead. Just look at this, what it is. Okay, now I will take a simple example and I'll explain. Now I'm taking a system which has a 32-bit physical address. Cache memory is equal to 32K. 32K requires 15 address digits. So index will be 15. And the tag is equal to remaining 17. Now let us see. I just want to divide this cache memory, that is of 15 digits, of different sizes blocks. One block size I will take, that is 16 words. One block is equal to 16 words. Okay, if the block is equal to 16 words, least significant word field, which is equal to the block size, as is of 16 words, the number of digits that are required to address the word field is 4 digits. 15 minus 4 is equal to the remaining number of blocks, that is 2 power 11 blocks. Each block is of 2 power 4 words. Okay, tag will remain the same, 17. Now see, here the number of words per block is equal to 16. If I just go for a reduced block size, that is, I just want to organize my block with 8 words. Okay, 8 words requires 3 digits because 2 power 3 is equal to 8. So at that time, this 15 will be divided into 3 plus 12, right? So When you affect the block size, number of blocks will get affected. If the block size is affected, then the number of blocks will get affected. It doesn't have any effect on the tag. Okay, let us go for even more simpler block size, that is 4 words. If it is 4 words, it requires 2 digits. So this 15 digits will be 2 plus 13. At that time, the number of blocks will get increased. If the block size is small, number of blocks will get increased in the cache memory. It doesn't have any effect on the tag size. If the tag size has to get affected, as in the previous question, the associativity gets either increased or decreased. Okay, if the associativity of the cache memory gets increased, then tag is equal to tag plus 1, block is equal to block minus 1, right? So if you want to affect the tag field, then associativity gets increased. So tag is associativity will get increased. Associativity will have a relationship with the tag. If the associativity gets increased, tag gets increased. Associativity gets decreased, tag will get decreased. More the associativity, more the tag size, because when we go for 4-way set associative or 2-way set associative, tag is equal to either tag plus 1 or tag plus 2. Direct mapping, simply tag is tag, block is block. Okay, so if you want to affect the tag, you should think about updating your associativity. Okay, but updating your block size will affect the number of blocks. It will give the number of blocks, it will give the size of the block. Okay, so now this tag will not get affected irrespective of the block size. The block size will not affect the tag. Okay, so it will be overruled. Okay, then a smaller block size implies a larger cache tag and hence lower cache hit time. That means again this will also be ruled out, because he's talking about when he maintains a smaller block size and then it affects the tag that it is going to be larger. It is not true, because the block size will never affect a tag. A smaller block size will not lead to either a lower cache tag or a larger cache tag. Smaller block size, rather, the block size will not affect the number of bits in the tag. Okay, only associativity will affect the number of bits in tag. So in that light, these two will get overruled or false. A smaller block size incurs a lower cache miss penalty. This is interesting. Okay, that is, try to understand. If the block size is smaller, that means that the number of blocks that can be accommodated in the cache memory will be more. I'll write it here. Smaller block size implies more blocks. Okay, so when we design the cache memory with more number of blocks, definitely the hit rate will be more. Okay, if the hit rate is more, it will affect the miss penalty, right? Hit rate is more, and then miss rate is less, so miss penalty will also be less, because there are more number of blocks. Every time CPU sends an address reference, there are more chances that address is likely to be fetched from the cache memory. So more number of blocks, more hit rate. If hit rate is more, definitely miss rate will be less and miss penalty will also be less. Okay, so what is the answer? Lower cache miss penalty. Smaller block size incurs a lower cache miss penalty. This is the answer.